infrastructure engineer at Quora, and today I am going to tell you guys about the story of how we've optimized performance at Quora over the last 6 years and how you guys can apply some of these lessons to make your websites blazing fast. So, for those of you who are unfamiliar with what Quora is essentially a platform to ask questions, get useful answers, and share what you know with the world. And in order to be the best platform in the world at doing that, we want to make sure that Quora is as fast as possible. So today I am going to talk about how we make that happen. Specifically, we're going to talk about 3 different categories of work that we've done, starting from measuring, how do we quantify speed? What are some of the actual improvements that we've done to speed up the site? And how do we maintain the performance of the site so that it doesn't get slowed down after you make these improvements later on? So let's get started with measuring. Quora, like many of the applications that you guys might use, is a server-side rendered application. So intuitively, when we first set out to start working on speed and measuring speed, our first metric to measure speed is server time. Pretty intuitive, right? But the problem here is that even though server time seems intuitive on our side to measure the computation time it takes for us to actually execute code that processes the request, in actuality, this doesn't necessarily reflect the user experience. Because when you're using an app or a website, you often experience things like network delays and intermissions. You have to wait for your HTML, JavaScript, and CSS to parse, download, parse, and execute before you even see any content on the screen. So when the only thing that we're measuring is server-side time, that leads us down to chasing down order of tens of milliseconds of improvement, when in actuality our users are spending maybe seconds just looking at blank page of HTML, waiting for content to come in. So based on our experience of kind of looking at this metric and optimizing for this metric, we learned that actually speed metrics need to be user-centric. Learning from these lessons, our next iteration of the speed metric is essentially this really complicated metric that is the weighted root mean square of user time, so end-to-end time, of how users are experiencing the site, weighted and normalized by platform, what device you're using, and country to approximate roughly what network speed are you expecting. If this metric sounds like a handful and it's really complicated to understand and complicated to explain, it's because it is a handful and it is really complicated to understand and explain. So what happens is once we have this metric out and we're trying to optimize for this, it's really hard for us to, even for engineers at Quora, to understand exactly what this metric is measuring. And when the metric gets worse, it's hard to know what might have caused it. Is it because all of a sudden a lot more people in rural areas are starting to use Quora and their internet is just slower than before? Or is it because we rolled out an iOS app that slowed down the site by 2x? It's really hard to tell. So based on this experience here, we essentially learned that speed metrics also need to be easy to understand as well as easy to debug. So taking these lessons, we essentially landed roughly 2 years ago at our current speed metrics, which is a simple average of speed index, a tool by Google that essentially measures how long does it take until different parts of the page becomes visible. So say the nav part becomes visible, that counts towards something. Time to interactive, how long does it take from you opening the Quora app or the Quora website and until you're able to actually interact with the first piece of content in a meaningful way. So things like uploading an answer, expanding an answer, or commenting on an answer, etc. And lastly, user action perceived time. How much time does it take from you actually clicking the upload button until you're able to get visual confirmation that this action has gone through? So for example, if you click the upload button and it turns from blue to gray and the text changed from upvote to upvoted, that's one way of getting that confirmation. So a simple average of these 3 metrics essentially satisfies all of our requirements. It's user-centric, it measures how users are feeling. It's really easy to understand because it's just 3 simple components. And when one of these components slow down, it's really easy for us to look at the subcomponents and understand, okay, the problem here has to do with time to interactive slowing down, so let's go deeper and figure out what's happening here. These lessons might seem pretty obvious in hindsight, but it's definitely something that we learned the hard way by making mistakes and iterating on our metrics, and a lot of other companies just starting out working on performance right now have made the same mistakes. So definitely keep those in mind if you're designing a speed metric. Cool, so next up, once we have a good metric, let's talk about how do we actually go about making improvements to this metric and actually making Quora faster. Generally speaking, there are two ways of improving performance. The first way is essentially trying to do work more efficiently, oftentimes by pipelining or parallelizing work. And the second way is by doing less work. Generally speaking, in performance, that generally leads to sending less data to the user. So let's take a look at each of these. The first technique that I'm going to talk about in the doing work more efficiently stage is a tool we call Parallel. So if you look at this page of the Quora feed, which essentially just has a collection of stories, which are either questions or answers or some other text, intuitively in a server-side render app, you might start rendering the story, just this entire page, top to bottom, right? So first you render kind of that first component in step 1, and in step 2 you render the second answer there, step 3 you render that question below that, etc. However, there's no reason for us to not start rendering the second feed story there before the first one is done, right? After all, they're fairly independent from each other. So a simple optimization one that people often think of is, okay, how about we parallelize that by sending each of stories to get rendered in different threads? The tricky thing here is Quora, like many other websites, is written in Python, which is an increasingly popular language, and Python is not inherently thread safe. So it requires a global interpreter lock in order to kind of simulate this multi-threading. So this doesn't quite work just because of the programming language. So one day in 2012, one of our early engineers had an epiphany. What if instead of simply trying to render each story in a separate thread, we just take a step farther and render them in different processes instead? So the engineers kind of spent a couple of days prototyping this, and he ended up with a tool that we have right now called Parallel. It's essentially a tool that looks at the components that exist on a page, tries to intelligently split them up into reasonably sized chunks. In this case, each chunk will be one story, one question or answer in your feed, and then simply sends off these chunks to other worker processes on the same machine to render them in parallel. Each machine renders these processes, sends them back to the server, the master process, and the master process then concatenates all of this HTML and sends it to the user. So that's pretty cool, and that reduced our overall kind of computation time and also improved our user experience by a lot. But that's not the full story. So what if we have a case here where, say, the first two processes are done rendering the questions and answers that they're rendering, but process 3 and process 4 will render the next two stories are still busy doing something. In a naive implementation, your master process is essentially waiting for all of the processes to complete and return the chunk of HTML before sending anything down to the user. So what that ends up happening is, from the user's perspective, you see something like this, where you see a blank screen until everything has been rendered and all of your content come at once. Instead of that, you can use this technique called chunked encoding, which essentially just means as parts of your HTML becomes ready, we send it to the user immediately. So after that, once the first story comes in, we send it to a user, second story comes in, we send it to a user. So even if the server is still busy rendering, say, the third and fourth answer question you see on your feed, you can already see some of the content and be able to interact with that content as you wait. So that's kind of the two techniques that I really wanted to talk about in the doing work more efficiently by pipelining work. There's a lot of other things that we've done here. Unfortunately, we don't have the time to go into all of those, so come talk to me afterwards if you want to learn more. All the techniques that I've talked about so far are actually pretty advanced. If you already have an existing app and you want to start adopting this, it might require some significant changes to your architecture. So next up, I'm just going to talk about a couple of the lower hanging fruits along the theme of doing less work and sending fewer bytes that you can essentially plug and play into your side project, hackathon app, or current company website and immediately get some speed gains. A lot of these techniques here are actually fairly well documented online, so I'm not going to go into too much implementation details. I'll just introduce you to some of the concepts on a high level, and you guys can look into that later if you're interested. The first technique here is called inlining critical CSS. Most of the time when you have an application, what we try to do on a web framework side is that they bundle all of the HTML and send all of that down to the user so that in the future visits of the site, users already have the CSS cache, like CSS bundling. Users already have all the CSS cached, so it doesn't have to make a separate request. Even though that's good for future requests, it's really bad if your users are visiting the page for the first time in several weeks, because then there's no CSS at all. User has to wait for this entire massive bundle of CSS to get downloaded before they can see any content on the page at all. So the technique here is essentially when you detect that this is the first time the user has come to your site for a while and there's no CSS cached, what we do is instead of sending this bundle of all the CSS for everything on the entire website, we first parse through the content of the page that we're about to send to the user, the HTML, and understand what are the CSS rules that are actually being used for this particular page. And then simply we take all these CSS rules, we just put them in a string and inline them in the HTML before the body. What that does, and then in the background, as the user is already interacting with this page, we can then fetch and download the main CSS bundle so that repeat visits can get this cache hit benefit. The second technique that I want to talk about here is called broadly compression. By default, when you have an app, most of the time the server is taking the HTML content, gzipping them, compressing them via gzip, and then sending them to the user, and then the user's browser then natively decompresses them. If you just simply swap out the gzip command with what's called a broadly, so it's a compression algorithm, it's a library that's, I think, open source by Google, you can immediately get a 20% size win on all of your static content. So all of your HTML, JavaScript, CSS would just immediately become 20% smaller without you having to do anything else. So that's pretty neat, because that means your users are downloading less data, and less data means that when they're on mobile phones and the internet connection is bad, they can still see your content much faster. Along those lines, there's also this tool called WebP, which is a new image format. So if your website holds any user uploaded images, such as, say, answer images in Quora answers, you can, instead of saving them in JPEG or PNG or whatever format the user is uploading them in, you can just convert these images into WebP, which saves 26% of the image sizes. So again, you don't need to do anything. The images don't look any blurrier or worse from the user perspective. It looks exactly the same, and you're saving 26% of the bandwidth, so you're not seeing kind of the image very slowly low line by line, and just reduce that experience. Cool, so that pretty much covers some of the high-level techniques on a doing less work phase. Again, there's a lot more work that we've done here, so definitely come talk to me. Next up, even though all this improving sounds really exciting, but really it's only half of the performance work that we would need to do. The other half revolves around the theme of maintaining. How do we make sure that we don't accidentally slow down the site in the long run, and build tools to help engineers understand the speed impact of their changes? So before I talk about that, let me just quickly go over a typical development process and what that looks like from the engineer's point of view. So first, you have some local changes on your local computer. You might be testing them, you're playing around with them. At some point, when they look good enough and you've written enough tests, you might launch an A/B test to test out this feature that you're testing, to see how users might react. Do they actually like it? Is it actually good for the product? Then, once you're pretty happy with their user reactions, you might launch this feature to 100%. So all of your users now are seeing this new feature that you built. Great. Lastly, you probably want to continue monitoring this feature and fix any bugs that might come up. From the maintaining part of view, the performance team at Quora essentially just build tools for every stage of this pipeline. So let's start from local changes. Say you're an engineer at Quora, you're building, testing out a feature. It exists only on your local branch right now. Nobody else has seen it. And you're wondering, I wonder how much my current change is actually going to slow down the site. And if so, how do I test that, and how do I iterate on that? We built a tool to solve that exact problem called perf test. It's essentially a simple shell command that you can type. And what it does is it uploads your code to a test server and then runs a bunch of simulated user requests against this test server. And at the same time, it also runs the production Quora code that's running on Origin Master, uploads it to a similar identically configured test server, and also run a bunch of stipulated user requests against that test server. And then what it tells you is it sends you an email that tells you with some amount of statistical significance, your code is speeding up or slowing down the site by roughly what percentage. So here, the text is a little hard to see, so I wouldn't worry too much about that, but you can essentially see that there's 2 red columns there, which means this particular change slowed down the site on these 2 pages on the web platform. So using this tool, you can iterate on your feature and making sure that you don't push any code to production that might potentially slow down the site. So let's say you've run perf test, everything looks great, you're ready to start an A/B test. We actually built a big tool here that's just integrated right into our A/B testing framework that essentially just measures performance against real user requests that are coming in to help you understand exactly, with way more data point than the simulated user requests that we're running before, how much your site is actually slowing down or speeding up. So here you can see that again, text is a bit small, but you can see that this feature has 1 green row, which means it's sped up server time by 1.4%, and it slowed down time to interactive by 6%. So that's the red column at the end. So before you even launch any feature to 100% of the users, you can already see roughly how does that impact your experiment group and potentially fix these issues before launching them to 100%. So next up, things looking great. You fix all of the regressions, you're ready to launch into production. Our engineers are constantly pushing code to production, and because of that, we built a lot of monitoring tools to make sure that when something in production slows down, we can catch that. But there's so many metrics, it's really infeasible for a human engineer to go in and look at all of these metrics every day because there are just thousands of them, and realistically, you can't expect anyone to know that. So we built an anomaly detection tool that looks at all of our high priority speed metrics and looks for step changes inside these metrics. So here you can see it used to be pretty fast, so the speed time is pretty low, and then it jumps up, and this jump is automatically detected by our anomaly detection system, flags that, and will create a task for whatever engineers own that tool so that they can look into it and figure out exactly what slowed down on their site. And lastly, when you get alerted that something has slowed down, to help you go about investigating these slowdowns, we built a lot of tools, such as Skyfall, which is a simple visualization tool that takes individual user requests and essentially shows you from the speed perspective what is the bottleneck here and what is causing this particular user request to be slower than you like. So in this specific instance, you can see that there's a top yellow bar that's kind of blocking all of the other bars later. So that's potentially one explanation for why this request is slower. And if you can reduce the width of that yellow bar, everything will become much faster. Cool, so in summary, what have we learned in the last 6 years? We've learned that to work on speed, we have to be able to measure speed by building user-centric, easy to understand, and easy to debug features. We've learned that we can make a lot of improvements by thinking about how do we pipeline work more efficiently and parallelize work more efficiently, as well as how to do less work and send fewer bytes. And we've learned that we need to maintain speed by building a slew of monitoring and debugging tools so that we can automatically catch any regressions before they happen. If you want to learn more about performance, we have there's a lot of resources online. There's conferences, there are these people on Twitter who tweet a lot, and I would recommend joining the Chrome mailing list to hear it from the Chrome developers talking about how to speed up Chrome and like all the websites in general. If you didn't catch any of that, don't worry. I write a lot of performance-related answers on Quora, including this exact one, which has a link to all the resources on the previous page and just a couple more articles going deeper into other topics I mentioned earlier that you guys should definitely check out. Cool, thank you very much. I think I'm out of time, so I'll take any questions outside after the session. Thank you.